My name is Agustin Bilbao from Aapresid. Today is Monday, 24th August. You are welcome to this session, which is Innovating Machineries for Weed Control. You will be able to send questions after each session. At the right in your screen, you can write your questions. And at the end of the session of the presentation, we will be able to have a Q&A session. Remember that in the main menu of the main website of the company, there is a button for participants. You will be able to click on that and see different things from the speakers and other participants, and you can communicate to them. Remember to visit a Aapresid space. This is in the main Congress website. You have the logo and very interesting things to watch. And you can follow us in social media with the hashtag Aapresid Congress, Congreso Aapresid. Peter Newman from Wheat Smart and again Coleman, both come from Australia. He was a student of agricultural science in Western Australia. He worked in the private industry as a agronomic engineer. He joined AHRI, which is the Australian Initiative for Wheat Resistance. In 2013, he is member of the communication manager. He takes the research of this institution and he also communicates other information related to herbicide-resistant weeds, and he communicates this to the agriculture industry in Australia. He's also an extensionist of the WheatSmart team, and he's a communicator of Wheat.com and yanfaracademy.com. I recommend this application. It's quite interesting. I started to watch it and I really recommend it. Guy Coleman is our second speaker. He's a scientist. He works in precision technologies area to control weeds in the grain research center. He has a degree in science in the Western Australia University in 2014. He had a degree with honors in the Sydney University in 2016. He researched on air vehicles, unmanned air vehicles. Quite interesting, this topic. Guy has worked in Norton-Sep research in United Kingdom, the Australian initiative to herbicide resistance in Western Australia, and the Colorado University in US. He has just completed the postgraduate program in the Water Resources Agriculture Department with regulatory science and other science. And so they both have excellent CVs. I've been following everything that they've been doing lately, and so let's use these interesting presentations. You can take the floor.
The Aapresid conference in 2003 and was gifted this lovely mate cup. Must be honest, I've never used it, but it makes for a great ornament. Great to be with you. I wish I was there in person again, but fantastic to be with you nonetheless. And I'm going to talk to you today about the weed destroying machines in Western Australia, capturing weed seeds at harvest for managing herbicide-resistant weeds. So we're the Weed Smart team. We're a team all around the country. I'll tell you a bit more about the rest of the team in a moment. We spend a lot of time trying to work out how to help Australian farmers manage herbicide-resistant weeds, and harvest weed seed control is one of those. Just let me share my screen and we'll get started. So Aapresid has finally invited me to talk about weed seed destroying technology at harvest. Now, a wise man once said to me, it seems crazy that we spend the entire year spraying weeds with expensive herbicides only to reward those survivors by spreading them out with a harvester so that we have something to spray next year. So we can intervene at harvest. We can stop the weed seeds reaching the ground. They've already set seed, but how many of those weed seeds can we capture and get the seed bank into decline? So Aapresid asked me to talk about weed seed destroying technology at harvest. We call it HWSC, or harvest weed seed control. So this is where I'm from. I live in Geraldton in Western Australia. We're in the northern wheat belt of WA, just in the northern tip of where we grow crops in Western Australia. It's a long way from Argentina. When I travelled there in 2013, we actually flew the other way around the world via New Zealand. But yeah, it took a long time to get there in a plane, but I had a fantastic time, and I wish I was there again, despite the long travel. But great to be with you using the technology. And there's a picture of me presenting on the big stage. It was one of the most difficult presentations I've done because of the language barrier and so on, but I really enjoyed the opportunity to be there. A little bit about Weed Smart. We are an industry initiative to communicate information to help farmers battle herbicide-resistant weeds. We are funded by all of these partners on screen there above the line, GRDC being a major stakeholder, and a lot of the chemical companies, Bayer and Syngenta, being gold partners. And as you can see, a list of other partners throughout Australia, chemical companies, seed companies, machinery companies that make the seed destroying mills and so on, and our in-kind partners below the line there. So we'll hear more about Weed Smart. This is our team. We're a team spread all around the country. There's me in the northern part of Western Australia, and our team all around the country, funded by all of those chemical companies and seed companies and GRDC and so on, to spread the message and help farmers manage herbicide-resistant weeds. And to do that, we have developed the Winter Big Six. So this is the Big six big things that farmers can use to manage herbicide-resistant weeds. I'm going to go through them very quickly, just so that you can see that managing herbicide-resistant weeds isn't just all about harvest weed seed control. There's a lot we can do. So it's about rotating crops and pastures. It's about the double knock to preserve glyphosate. So often that's glyphosate followed by paraquat for us. There's other forms of the double knock. There's mix and rotate herbicides. We used to talk a lot about herbicide rotation. We now talk a lot more about mixing herbicides and mixing and rotating herbicides. Mixing is even more effective than rotating, and mix and rotate is more effective again. We have our tools to stop seed set. So that's our crop topping, spray topping, cutting hay, that sort of thing. And we have crop competition to compete with the weeds. So row spacing, seeding rate, orientation, north-south versus east-west, soil health, those sorts of things, crop variety traits to enhance crop vigour. So crop competition. And the final one there, harvest weed seed control, removing weed seeds or destroying weed seeds at harvest. That's one of the big ones, and that's what we'll be spending the rest of the time on today. So this is some focus paddocks that I monitored with GRDC funding for about 15 years, and the monitoring is still ongoing, but I just have the chart going up to 2015, where we monitored farmers' paddocks to see how they were doing with their ryegrass numbers. So we just count ryegrass in spring, just before the crop is harvested each year. And we can see there that the Plus Harvest Weed Seed Control group, they managed to erode a big ryegrass seed bank quickly and then keep it pretty much on zero from then on. Whereas the Minus Harvest Weed Seed Control group, they were very effective at controlling weeds and getting their seed bank down, but they always have that residual population of 5 to 10 ryegrass plants per square metre. Now that doesn't sound like a lot, but they can set 1,000 to 2,000 seeds per square metre. So every year we have weeds to spray. Now, I need to point out that harvest weed seed control, a lot of these tools is all about that seed bank and all about running down that seed bank through time. When I was in Argentina in 2013, I learnt that you have a lot of 1 year land rental, or a lot of land rental in general, and very short-term land rental. So it can be hard to take this long-term view. And so this is, in these Australian farms, often owner-operators, the farmers own the land and farm the land. And there is lease land, rented land, but a lot of farmers own their land and they can take a long-term view. So for Argentina, it gets a bit more complex. I assume you still have that short-term land rental. But what I would suggest is perhaps we might get to a point there to manage resistant weeds where the owner of the land might have some stipulations that maybe you need to practice harvest weed seed control, you need to mix and rotate herbicides. They might be able to stipulate some of these things to help run down the seed bank on that rented land, which is going to be good for both the owner and the renter. So we have a number of harvest weed seed control tools. We have narrow windrow burning, chaff lining, chaff decks. We have the chaff cart, bale direct, and then the seed destroying mills, which is the HSD, the seed terminator, and the ready cop. I'm going to spend quite a bit of time on the seed mills today, and then I'll give you a bit of an update on what's happening with the other tools as well. So we've seen in recent years big developments going on here with these machines that can be fitted to the rear of a harvester to destroy weed seeds as they exit the harvester. So we'll show you the mills in a moment, but there are now a few different options. There's the seed terminator, there's the ready cop SCU, and there's the HSD, the Harrington Seed Destructor. Now, all of these machines appear to be destroying 95 to 98% of the weed seeds that enter the mills. And importantly, for you no-till farmers, this is the no-till farming conference, returning all of the residue to the field. So some of our harvest weed seed control tools are removing some residue. We want to retain as much residue and the nutrients contained in that residue, and that's where these mills have a really good fit. So it all started, well, it started with a tow behind Harrington Seed Destructor, and then that moved on to a hydraulic Harrington Seed Destructor pictured here, but that's no longer in production. But now the options that we have is we have the vertical HSD, the Harrington Seed Destructor, that is belt driven with vertical mills, so no more hydraulics. And instead of the mills being horizontal, they are mounted vertically on the back of the harvester. There's a rear view picture of the Harrington Seed Destructor, the chaff falling into this box here, hitting those augers and moving sideways into the vertically mounted mills where the weed seeds are destroyed. We have the seed terminator, another option. This is belt-driven horizontal mills. You can see mounted under the rear of this harvester, and a very good option, very high seed kill rates, and once again that belt-driven option without any need for hydraulics. And then the most recent mill on the market is the ReadyCop SCU seed control unit. This one pictured here is fitted in combination with a MAV chopper. So ReadyCop sell MAV choppers, and this one is the mills fitted with a MAV chopper, this time to a John Deere harvester. It is a combination of a belt and a shaft and gearboxes driving those mills. And once again, these mills are horizontal in nature. So they all are getting that high level of weed seed control, but they have slightly different mills. You can see on the left of screen there, the ReadyCop mill. They are all, these three mills are all like this. So they have these three rows of stator. The stator is the stationary part of the mill that's mounted to the machine. They have the three rows, and within that, two rotating sections, the rotor, and then a fan in the middle. So we can see the ReadyCop on the left has some sort of vertical bars. The seed terminator in the middle is more screens that the weed seeds are pushed through, and the HSD on the right is more bars that are on an angle with the rotor inside it there. So they are bars a little bit like the ReadyCop, but they are different bars and they are mounted on an angle. But essentially, they are very similar in nature, these mills, in that they have these stators, three rows of stators, and then two rows of rotors, the rotating part, and then a rotating fan in the middle. So this is a picture looking from the inside of the seed terminator. We can see the fan blades there, that the seeds enter the top of the mill, hit those fan blades, and they smash them into the first set of screens, and then there's 2 rows of rotors in behind that smash them into the following screens. That is actually a picture from the inside of the Redicop SCU, similar to the others in that they have these fans in the middle. These ones are fans made out of chopper blades, I think, and those fans smash the seeds into that first row of vertical bars, and then there's 2 more rows of rotors coming through. Also, there's some other developments going on with the mills. This is a seed Terminator mill that the dog is sitting in there. They actually have a mill where they remove the outer cage, so they just have the 2 rows of stators there and remove the outer stator, and that's what they call their high capacity mill. So that is when the show must go on. If there are blockages or if the mill is slowing harvest down, they can fit this mill pretty quickly, change out to this one and keep harvesting. It doesn't give quite as high seed kill as the other mills with the 3 rows of stators, but can give high enough seed kill to be very valuable and keep the machine running. So good to see that the mill companies have different options coming out. They have different work with the hard facing of the mills and the materials that they're made of to try and get a lot of hours out of each mill. The mill life is anywhere from 200 to 800 hours for a set of mills, and there's a lot of work going on to maximise that. Ultimately, most of the companies are trying to achieve a full harvest with one set of mills. Now, the question you're probably all asking is the capital cost. How much do these things cost to fit to the back of a machine? Now, I've just taken the Australian prices and converted them to US dollars with an exchange rate of 70 cents. So 70 cents US buys $1 Australian dollar at the moment. So the retail prices in the US or in Argentina will probably vary from this. I'm not sure where they'll end up, but this is just taking the capital cost in Australia and converting it to US dollars. So the HSD is the cheapest one at 63,000 US dollars. The Redicop, $77,000, and the Seed Terminator, $84,000. So there's different components in there that make up these different capital costs. For example, the Seed Terminator has a big gearbox to convert the drive from this way to this way. And so there's a gearbox there, and their screens and so on are designed differently. The Redicop has a belt and smaller gearboxes, and the vertical HSD, because it is vertical, has no gearbox. So that helps make the capital cost a little bit lower. If we convert that into the approximate cost to operate in dollars per hectare, you can see it's in that $8.50 to $9 per hectare US to operate. Now this includes that capital, includes extra fuel, wearing parts, a 10% reduction in harvest capacity. Sometimes farmers find a bit of reduction in harvest capacity and sometimes not. That can vary. And it is based on a 4,000 hectare Australian farm. So we have a calculator on the WeedSmart website that you can use. It is in Australian dollars at the moment. Our American friends at Grow are converting it into US dollars, and that will be, you can use that, you can download it and use that to estimate the cost of the different harvest weed seed control tools for you based on your crop area and so on. Now we find with the mills, what we in the industry have talked a lot about is that seed kill percentage and the capital cost. But then we find the farmers talk about, will it slow me down? What are the wear rates? Will it block? How much does it cost? The maintenance, the cost of the replacement mills, the ease of service, the support, and the seed kill. So we have probably different priorities in terms of what we think matters most. And we're finding that most of the mills are killing seeds and they have their given capital costs, yes, but the farmers are really sort of wading through now which mill to choose based on this other big long list. And we have all the different mills in competition with each other. They're all doing a great job of supporting farmers and making their machine more reliable, and the wearing parts last longer and so on. So that decision of which one to purchase comes down to individual farmers deciding on what they find out about things like reliability and will it slow them at harvest and that sort of thing. And it's a very competitive market, and they're all doing very well. I just want to move on now to some of the other harvest weed seed control tools that are not the mills. So we have chaff lining. This is a very good place to start. I'm aware that there is some of this happening in Argentina already. So this is just taking all of the chaff off the sieve and putting it into a narrow chaff line using a chute like the one pictured and leaving it and then hopefully putting chaff line on chaff line year after year. So we don't have to be a full controlled traffic, but can we drive the harvester in the same place every year? So there's a range of different chaff lining chutes. This is another one that a farmer made on a John Deere harvester near me in Geraldton. This is called Tarp Line. This is a farmer in Victoria who made one out of a flexible PVC tarp, so it shakes around. And this is the commercial one on offer in Australia from West Oz Boiler Making, so farmers can buy it and fit it and know that it works. A little bit of research here. John Broster and Michael Walsh did some research, and this is a particularly good piece of research in chaff lining. It won't always work out like this, but what they found was they measured 1 metre of chaff line at harvest and found that there were 2,237 ryegrass seeds in that metre. It was a weedy bit of crop. They went back just before the rain started to fall in winter, or just went back in autumn, just before seeding, and found there was only 300 seeds left. Not sure where they all went, perhaps predation from ants and so on. And then they came back during the crop, once the crop was up, and found that there was only 7 weeds had come up. So we're finding, this is a particularly good result, I should add, but we're finding that the chaff lines often are cleaner than you might expect. So a good place to start. We also have the EMAR chaff deck, a similar sort of approach, but we're putting the weed seeds on permanent tram lines. And this is the chaff deck in operation. And we also have some farmers that have chaff decks, then they find these very weedy strips in their paddock, and they are managing to go and spray just those weedy strips with a more expensive herbicide brew and control the weeds just using an expensive brew over a small percentage of the paddock, and they call that weed lining. Narrow windrow burning is one of our older practices. We're seeing people disadopt it now because we're trying to reduce the amount of burning and the amount of nutrient removal, but it essentially involves taking everything that comes out of the harvester, putting it into a narrow windrow and burning it just before seeding. Very effective, but nutrient cost is high. We also have the chaff cart, catching all of the chaff, putting it into the cart, leaving it in dumps. They're often burnt, and then, or they are grazed, and we're finding big benefits of farmers grazing chaff dumps with sheep. And this is where the chaff cart really fits these days for mixed farmers with sheep in the system. And finally, the Glenvar Bale Direct, baling everything out of the back of the harvest with the baler. This isn't as common in Australia, but there are some people that make good money out of it because they have a good market for the bales nearby the farm. Now, we need to remember that all of these things, it depends on how much weed seed retention we get of our different weed species. So that's something you need to measure in your country. For your different weed species, what percentage of the weed seeds can you get into the front of the harvester? Then what percent can we divert into the harvest weed seed control tool? And then what's our seed kill? So for example, with ryegrass, we can often get maybe 75% of the ryegrass in the field into the front, divert 95% of that into the tool, and then destroy 98% of that, so getting 70% seed removal in total. For more information, there's a really good report on the WeedSmart website done by the Condinen Group, comparing all of the different tools. There is the link there. And don't forget the WeedSmart Big 6. You can check that out on the WeedSmart website. Thanks again to all of our WeedSmart partners and the WeedSmart team. And I'd just like to finish where I started. It seems crazy that we spread these weed seeds back out at harvest. We have the tools now to control a lot of these weeds. There's a number of different tools that come at different costs and different options there. But let's start using harvest weed seed control to drive down the seed banks. And as I said at the beginning, this is good if you're an owner-operator, if you own your farmland in Argentina, but it might be something that if you rent land to somebody, you might start to demand as a practice that you'd like to see happen on your farm. So thank you very much for the opportunity to speak to Aapresid, and hopefully we have some good questions in question time soon. I'm Peter Newman. Thank you very much.
Good morning, everyone. My name is Guy Coleman, and I'm a precision weed control scientist at the University of Sydney. My research has two key areas. The first is on weed detection to work out where weeds are located in a field. And the second is on alternative forms of weed control. So in this presentation today, I'll go through the innovations in both detection and control, and we'll look at what's available currently and then what might be available in the future as well. So I'll just share my screen. And if you'd like to follow any of our research, I'm on Twitter at Geezer Coleman, or the research lab at Weed Control Lab is where we share some of our research as well. As I'm sure many of you will be well aware, weeds are not evenly distributed throughout a paddock or a field. So in areas where there are no weeds, we often might apply a weed control treatment anyway, when in fact we really just want to focus it on those areas with either patches or some less dense patches, or even just the individual weeds themselves. So the whole driving factor behind site-specific weed control is the desire to treat weeds on an individual basis rather than treating them on the paddock level or on that area basis. And so that's what sets up the design of a site-specific weed control system. So the first part of the site-specific weed control is the sensor. So this works out or provides information on the surroundings, and if there is a weed, it will send that data to a processor. So the processor then decides, based on the information from the sensor, using an algorithm that you've trained or parameters that you have set it, whether or not a weed is present in that information. So now that sensor could be an ultrasonic sensor, so it could be a stream of distances, or it might be a weed or weed seeker sensors with optoelectronic sensors that detect differences in reflectance. And so again, it has to work out if that information does contain a weed. It also could be cameras, so that's where we deploy those deep learning algorithms that I'll get to later. But effectively, that information from the sensor is then analyzed by the processor and the weed detection algorithm. And if a weed has been detected, then a signal is sent from the processor to a controller. The controller might be then connected to a nozzle or a targeted tillage or even a laser. And that delivery of the control then occurs to the plant. So basically, it's a three-step process. You have the sensor, you have the processor to detect the weeds, and then you have the controller, which delivers that control, whatever it may be. And this is the three steps of site-specific weed control. So keep this in mind as we go through this presentation. So weed detection isn't necessarily anything new. This is from the 1980s, and this is in Western Australia, where people were looking for scales and weed, Chondrilla juncea, in fields. And this modified tractor type bit machinery, basically people would sit on it and they saw a weed, scales and weed, they'd jump down, mark out the area, someone would come back later and get rid of that weed. So it was effectively a form of map and control, mapped out the weeds, and then someone came back later with the weed control device. So we're trying to do that these days, but we have a different range of technologies available to us. And so this is all about the level of scale and what sort of precision that might give us. At the least precise, or sort of the greatest scale, we have satellites. So satellites resolution is often in the meters to the tens of meters. The best resolution is probably around the 50 centimeter, the sub-meter level. And what that means is it's pretty useful for patch mapping. So individual weed detection would be difficult because the weeds are often going to be smaller than the pixel size, so they're going to be lost to background noise. But it can map patches, so in some circumstances, this could be quite useful. Then there are drones, so another aerial approach, and drones can be fitted with very high resolution cameras. So these cameras can provide sub-millimeter levels of pixel size, and they have been used to detect even small insects on leaves in cotton fields, even very small disease markers, and also weeds. So it means we can get that individual level of weed detection that is useful for weed mapping. And I'll show you an example of this shortly. They are restricted in the ability to fly them in all types of weather, and also there are regulations on how you can use them in wherever you are in the world. They do differ, so it is slightly more difficult to use them, and they do have those payload and flight time considerations too. Though again, there have been drones built with sprayers sort of inbuilt. And I know John Deere at Agritechnica was showing off the volocopter with that large, I think 9-meter wide boom that was mounted to it. So it is feasible that they can deliver weed control. It's just they have some restrictions and limitations on them. So then there's ground-based weed control devices. So here is an autonomous field robot from the University of Sydney's Centre for Field Robotics. This is the Ripper. And that's just one of many different types of platforms that weed detection and weed control could be mounted to. So we also have those large self-propelled sprayers or tractors, autonomous vehicles. It might be driven, it might be autonomous. But the important thing is that ground-based implements don't have the same restrictions on sort of weather or weather permitting, those types of things. Obviously, there are limitations with ground-based implements, but they aren't quite the same as the drones. So we can fit them with larger booms or larger weed identification methods. And so these are the sort of the types of detection and control options I'll be focusing on today. In saying that, I'd like to show you one of the UAV options that exists, so the map and control approach. And this has been implemented in Australia in some forms as a first step into site-specific weed management with existing technology. So what we have here is a boom with, say, 5 sections in it. Your boom might have individual nozzle control, or even no nozzle control at all, or no section control, and you could just turn the whole boom off and on. But in this case, it's section control, and the UAV has been flown, it's found weeds, it's used a GPS to locate where the weeds are in the paddock, and then that has been exported to a sprayer. So the sprayer then only delivers the herbicide to that grid, or the size of the grid that you provided it. So it's not super precise, but it does reduce herbicide usage and wastage without any additional expensive purchases of new sprayers or new camera-based equipment. So it's a great sort of first step into the site-specific weed control domain. And this is just an example of what we did with the University of Sydney's Goldacre sprayer up in Narrabri. So the UAV was flown, the weeds were detected with these outlines here. It's quite a jiggly video, I apologise. And then as it flies, as the sprayer drives over these areas that have been identified on the map, you can see these sections activate down here in green. So it just shows that only the sections needed activate instead of spraying this area that doesn't actually have any weeds in it. So it's a great first step, as I mentioned, for site-specific weed control without purchasing large weedits or weed seeker booms. Then we get into the fallow weed detection, so the ground-based real-time weed detection and control. And so, as I mentioned, these are the weedits and the weed seeker 2s, the Quadra or version 2s of each of them I've mentioned here. But basically, they just sense differences in reflectance between the living green plants and the brown dead background. They work very well on low weed densities. If you have very high weed densities, then it tends to spray the whole paddock anyway, but they have resulted in significant savings in herbicide. I think some trials in Australia reported up to 78%, but they convert that previous thinking about controlling the whole paddock with the same control into that site-specific weed management. And in most cases, they are connected to nozzles. But what I'd like to show you is that if you think back to that initial diagram, the site-specific weed control system, the final step doesn't have to be a nozzle. It can be a tine. And so my supervisor, Dr. Michael Walsh, was working with the University of Western Australia on developing what is essentially targeted tillage. So the weed identifies the weed, the tine comes down and chips out that weed. Instead of ploughing everywhere, it just gets that weed. So it's a way of adding a new form of weed control to an existing detection and processing sensor. But as we move into more complex scenarios, so in-crop weed control, the level of sophistication needs to increase. So before we could use the green crop and the brown background quite effectively with the sensor-based approaches. But if we want to, say, detect a broadleaf in a wheat crop, then everything is green or shades of green. And so it needs an additional level of sophistication that comes in the form of cameras. So cameras provide data in the form of images, and those images can be analyzed for color and shape and texture to detect these weeds. And they provide us with that extra detail, extra data that can be used by machine learning algorithms to detect weeds. And there are a few players in the space at the moment. So we have Bilberry, they're a French company, but they are working in Australia with AgriFac on providing a boom, self-propelled sprayer that has cameras fitted to the boom to detect wild radish in wheat. There's an Australian company, Autoweed, that are doing a similar job at detecting green weeds in a green or crop background. So they have focused more on pasture and sort of rangeland grazing. In America, the Blue River was bought by John Deere, and that's in sort of more controlled environments, so in cotton crops. And again, that's green on green technology. What's also important about these is they can do green on brown as well. Because they're a camera, they can do weed detection in a range of scenarios. Then we get to the really complex scenario of grass weeds in cereals. And while this is very much an active area of research, people are looking into how this can be best detected, it is a difficult and complex situation. So we've yet to see any significant commercialization, I guess, in this particular setting. So machine learning algorithms are the best bet at managing the variability in both on a farm, so between your fields, and also at the national or the between farm level, where there's significant variability in farming systems, backgrounds, those types of things. So machine learning has shown a much greater ability to manage that variance in data than previous attempts. And that's why it's really taken off since around 2012, when deep learning specifically was sort of shown to be better than other previous forms. But importantly, these algorithms require manual training data. So we have to tell the machine what a weed is. So here we've identified all the wild radish, drawn boxes around them for the object detection algorithm. And then it learns the similarities between each of these boxes and the differences to the crop as well. So the way it does this, we have to sort of dive into the image a little bit. And an image to a computer is effectively a set of numbers. It's completely meaningless to us, but to a computer, that's all it's got. So just as an ultrasonic sensor feeds a set of numbers into a processor to detect a weed based on height, a camera feeds a set of numbers in the form of an image into a processor to detect weeds based on a much more complex algorithm, the machine learning algorithms. And so if you zoom in the image, we can see that the low or the dark areas and the low numbers, that's where the information is less intense. So there's less light here, so the numbers are lower. In areas where it's sort of greener or brighter, then the numbers are much higher. And there are 3 values for every pixel in an image. So there's a red value, a green value, and a blue value. This is obviously just for red, green, and blue visual spectrum cameras. And each of those numbers, when mixed together, gives you the output color that you see on your screen right now. So the black background will be very much 0 or very low, and then any white text is 255 in all 3 channels. And so that's what the algorithm then uses to try and determine color, texture, shape. So this is a line here, so we can work out that's an edge of a leaf potentially. And that's all that it has to work with. But there are a range of different weed detection algorithms that are out there. It's not just sort of one fits all. And so while there are different algorithms for each of these types of output, they just perform separately and have their different strengths and weaknesses. So as we go through them, the lowest level of precision is image classification. So it simply tells us whether or not a weed is in the image. So you see some turnip weeds and a wheat row. Then there's object detection. So that gives us more of a regional understanding of where the weeds are, but it still has some the gaps of soil that aren't necessarily a weed, even though it's drawn a box around that area. So it's quite high level precision. I mean, these are only a few centimeters wide, but it might not be enough for those targeted approaches. And what you should also keep in mind as we go along these different types of detection algorithms is that the more precision you get, it often results in a much slower and a more complex algorithm. So the performance in terms of speed is less. And over time, that will probably come down and they'll become faster, and processes will become faster as well. But at the moment, image classification is the fastest, or tends to be the fastest, and then object detection about the next fastest. And then as we get more complex, it slows down. So semantic segmentation is the next level of precision and really another step up, because it goes to the pixel level in the image. So every pixel is classified as a turnip weed or not, or whatever classes you might have. So it could be turnip weed, it could be wheat, it could be a background class. And we just get the clumps. We don't get individual turnip weeds themselves, which is where instant segmentation comes in. And that's really exciting, because instant segmentation gives us individual weeds at the pixel level. So that means we can get some really targeted approaches to every single weed in this frame on an individual level. So perhaps we could get lasers to target the centers of these plants, or even sprayers only to spray just the leaf area. And this is the highest level of precision that is currently available. There are different algorithms that can detect plant structures. So we can label plant structures separately. So growing points, nodes, sort of flag leaves. But this type of segmentation is probably at the level of research where it's sort of just beginning for large-scale sort of wheat and irrelevant weeds. It is present in other industries. So horticulture, they do use instant segmentation quite effectively for individual weed control, though that is in a very much more controlled environment. So the complexity is moving us up into large-scale cropping systems. So, and it is constantly changing. So even by the time this video is watched potentially, or down the track, there will be advancements in this space that might offer more detection of those growing points or of the plants at a greater speed or a greater level. So sort of keep an eye on this area as it develops. So if we were to design a spot sprayer, I thought I'd just take you through the specific components that are present in one. So we have the camera that sort of sends that data of the image through to the processor. Then the processor has that weed detection algorithm. So it might be object detection, might be image classification, probably not necessarily required to have those higher levels if you're just using a nozzle. But anyway, the detection algorithm will provide the information if a weed is detected, and the processor signals a control board to activate a sprayer, and the sprayer then controls the weed. And importantly, the time it takes for the processor to detect the weed dictates how fast you can go. So how fast you can go from your camera through to the delivery of the spray. And the distance between the camera and the sprayer is also sort of influences your speed as well, because it gives you more time in the delay between seeing it and then doing something about it. So this is what that looks like at the detection phase. So this is a lupin crop, and you can see as the weeds are detected, it activates a nozzle in this app that we put together. And I was just showing the functionality of it. So you can change the number of nozzles quite easily, and it's quite a flexible setup. And this is using that object detection algorithm. And then if we look at the delivery side of it, this is a quad bike platform just testing out, again, that same algorithm on a lupin crop, and it's detecting the blue lupins and then spraying them. This is still in the early phases of development, I guess. It's just sort of testing it, see how it works. And the real sort of large commercial machines do run quite a bit faster. But excitingly, green on green spot spraying is just the beginning, because we can use these algorithms for a targeted alternative system where we have a camera, we have a processor that uses a weed segmentation or one of those more detailed algorithms that can detect, say, a growing point. That information must be then fed into some form of tracking and targeting. So it is another level of complexity again, because they are so targeted, you have to manage that direction of the laser very, very accurately. Then the end effector, which could be a 2-axis delivery system, moves the laser and then targets that growing point. So we thought this was pretty exciting and decided to look at laser weed control as an opportunity of a very targeted method. So it's relatively low power. As I said before, it is very specific where it targets that energy, and it's adjustable. So you have different beam widths, different energy levels, and different laser types. This is a near infrared laser, 25 watts on some ryegrass and turnip weed, an experiment we conducted last year and are continuing. So at the 2 to 4 leaf stage, there was decent control at the highest energy delivery levels. So this is 6 joules per square millimeter. It was a 5 millimeter beam width. And basically it shows that we can control weeds with higher energies. This corresponded to a 60 seconds of treatment, but it was only 25 watt laser. So if we increase the power of the laser, we can deliver the same amount of energy in a much, much shorter time. And turnip weed, we had similar results, perhaps a little more sensitivity at the lower end of the power range. And that might be because of the growing point located above the soil surface. And this is a short video just showing what the laser looks like as it hits that weed. You can see it hitting up the cells. This is 3 times speed and delivering that energy to the growing points and likely killing that weed. This is, we didn't run this through to the end. But say we have a weed like this, is this the type of laser we might need for it? And that's sort of where our research is looking. Can we get larger lasers to control really large weeds that are relevant for large-scale cropping systems? So I really hope you enjoyed this presentation. Feel free to check out our research on Twitter or ask me any questions by email. And looking forward to hearing from your questions today. Thank you.
Hello, everyone. I'm Peter Newman from WeedSmart.
Bueno.
Muchas gracias, Peter and Guy. I have to say that your presentations were very good. Now we can start with the Q&A session. Some questions for Peter, some questions for Guy. And we are going to, the first question is for Peter. It's more holistic, related to control tools. And in Argentina, we have problems with the society in wheat treatment. Some farmers were taken to jail, and we are not allowed to apply 1,000 meters away from cities. Do you have this problem of the distance that herbicides have to be applied at least 1,000 meters away from cities?
No, we don't have those sorts of restrictions in Australia. We're quite lucky, and our motivations to using non-herbicide weed control are mostly just about managing herbicide-resistant weeds, not because of restrictions on herbicides. Australia is we're quite remote, if you like. We have in Western Australia one big city of Perth, and not much farming very close to Perth. And then our farming, we have towns in our farming regions, but we don't have many problems with spray drift into cities and so on and causing restrictions. So not a big problem for us. And yeah, while our non-herbicide weed control helps for such restrictions, it's not a replacement for herbicides. We still need our herbicides.
Buenísimo, muchas gracias.
Great, thanks. A couple of questions for Guy, and then I'll go back to you, Peter, on a technical note. But the other part is very important to us as well. One of the questions for you, Guy, is those images that you showed on mechanical control with it or with Zicket, that's mechanical control killing the weeds. Is that being used on the field a little, a lot, not at all?
The tillage or the use of those weedits for the tillage to come down on a site-specific basis is sort of just starting in the commercial phase. So we have done some field level tests. So in Aapresid, we treated half or just around half a hectare, but it has been used on farms on the East Coast for testing, but it is not yet commercialized. Or it's in the process, it's just starting.
Buenísimo.
Great, thanks. And another question for you. The cameras that you're using still at the test level, are they detecting certain weeds specifically or the crop? And applying the weed control product to whatever is non-crop. Is the question clear? I mean, they detect everything and they just apply the products to whatever is not the crop without identifying what weed it is.
I understand the question, I think. The cameras detect, they can detect either weeds as well as the crop, or they can detect everything except the crop. Often it is more accurate if they are trained on both the crop and the weed. because if the weed and the crop look quite similar, the algorithms perform well if there are defined boundaries between what a weed looks like and what a crop looks like. So they might do better if they are more specific in what they are trained on. But most algorithms might at the moment seem to be trained on just identifying weeds as a whole group, and potentially as well as sort of individual species. But there's still a fair bit of research to look at how many species you might be able to detect, or the impacts of a range of different training or labeling on algorithms and their accuracy and performance in the field.
Buenísimo, muchas gracias.
Thank you. Your presentations were very clear because there are not many questions apart from what you had just said. This is a question for Peter. We have a doubt related to the crop yields, especially regarding seed destroyer, not the chaff lining machines, but rather the mills that destroy the wheat seeds. Compared the wheat yield and the speed of the harvest. We, in some parts of our country, we have wheats with a yield of 5,000, 6,000, and 7 kilos per hectare. And depending on the harvester, the harvest runs 6 or 7 kilometers per hour. Would this reduce the harvest rate or the harvester speed? I mean, what are your tests? Up to how many kilometers per hour does it work okay? What is the performance?
It's not really a question of kilometres per hour. It's more a question of how many tonnes per hour a harvester can harvest. And so if we have a class 8 harvester that might harvest 40 tonnes per hour of wheat, and regardless of the crop yield, it should be harvesting at 40 tonnes per hour. So the amount of chaff that goes into the mills is the same, really, regardless of crop yield. What we do find is that there is a drain of horsepower. There is a power requirement to drive the mills. And so generally speaking, farmers and the makers of the mills suggest that if you have a class 8 harvester and you put the mill on, then perhaps it will then operate at class 7 capacity and so on. So a class 9 would operate at class 8 because we need, I think, roughly 70 or 80 horsepower to run the mills. So we do reduce the total harvest capacity to drive the mills. We need to put some power into the chaff to destroy the seeds, but the crop yield shouldn't matter too much. As long as if the harvester is harvesting at full capacity, it will harvest at full capacity whether the crop is 3 tonnes per hectare or 6 tonnes per hectare. The one problem that the mills can have is green material when harvesting the crop. So when the crop is nice and dry, there's generally no problem at all. If you have green material or damp material, that's when blockages can occur. So it depends if your harvest generally has lots of green plants or green stems on canola, for example, or whether your soybeans are completely dry if you're harvesting soybeans. But for crops like wheat that are very dry at harvest, there's generally no problems.
Bueno.
Thank you very much. Okay. This will be the last question for Guy. Thank you very much, Peter.
De los equipos comerciales de las...
What's the percentage of commercial sprayers in Australia that are fitted today with targeted application? I understand that the ones available on the market are Weed and Weed Seeker. What is the percentage of the current sprayers that are fitted with this type of equipment in Australia today?
Thank you for the question. I'm not sure the exact percentage.
No estoy.
Using weededs or weed seekers. They are being used, but not extremely widespread. So maybe Peter even might have comments on this, but I think it's still something that is probably not as widespread as it could be, I guess.
Buenísimo. Bueno,
Very well then, thank you very much. Thank you both Peter and Guy. One last thing I would like to do is share a comment. What we have seen here is, or what you have shown is very necessary in Argentina. We have absolutely nothing about the equipment used in Australia for managing seeds from the harvester, and it's very important that we start using this technology so that we will only be able to improve the use of herbicides, but also integrate different things, seed management during harvest, all the way through to targeted applications. Here in Argentina, some 4% of the equipment used, of the sprayers used, are fitted with weed or weed seeker, and that's a very low percentage. So in order to improve weed control, we should resort to different modes of action to bring down costs and also to become friendlier with society as far as the use of agrochemicals is concerned, because there is a call by our society to reduce the use of agrochemicals. Thank you both. It's been an honor to have you here today. Thanks to the audience who has been following the two presentations. Thank you very much.